on module 2. Okay, so class, discuss in the module 2 we'll be discussing about the stacks, queues, their implementation, their applications. Okay, so here we'll be starting with module 2. So first we'll be starting with the stack. We have seen a basic idea of the stack. So what is a stack? Just revise the concept once again, guys. What do you mean by stack? So I have given one example of the stack, a stack of books. So can you in short tell me about what is a stack? Yeah, I think we have given one introduction about the stack.
Collection of elements.
Collection of element cannot be the stack. See, I'll tell you one thing. Once again, I'll come back to the module 1. In the data structure, we will be having a lot of data, but the way that we are going to store is different. The way that we are going to store the data is very different. In the data collection, we will be collecting the data and we need to store them. But the way that we are going to store, the structured, how we are going to store the data, that is different, and they are classified in that way. This data structure, the classification, if you see, they are classified in that way. Stacks has a different arrangements, queue has a different arrangement, linked list completely different, tree and graph even they have a different arrangements. Only every data structure is going to store the data. Only the difference is their arrangement of storage is different. In the stack, let's assume we have these different kinds of books, but they have stored one above the other, one above the other. So what happens if here, let's see guys, if here there is a one table, let's assume I'll just draw one table, and these books are kept above the table like this. Let's assume this is a table, okay, and these books are kept above this table, uh, and other books are kept one above the other. Now this arrangement, what you are seeing, is called as a stack. What happens here, one end is closed, you cannot make insertion of the element from this as it is closed, but the above end which is open, what happens, we used to first keep this book, then this second book, okay, first, second, third, fourth, okay, fifth. Okay, this is what the insertion I have done. I have put up the element. But when I want to delete or fetch the book from this stack of books, I will be getting this book first. Okay, so this will be the first element. Okay, so I will consider this is the first element that I'll be fetching. This is second element, third, fourth, fifth, sixth, seven, eight, nine, and 10. Here also I'll say this is the fifth, sixth, seventh, eighth, nine, and this is 10th. Now what you can understand here, the book which was placed on the table first, we are able to remove or we are able to fetch it at the last. This was the first book, okay, which was we have kept on the table, but we are able to access it at the last. Okay, so this is what I can say. Input is first in. We have first inserted these books on the table, but we have we are able to move it out. We are able to move it out at the last. So first in, last out. This is the technique we are going to follow, or this is the approach we are going to follow in the stack. First in, last out. Okay, that's what we have discussed in the earlier classes also when we have talked about the stack. Whether you people understood this approach, how this the storing and fetching out works with the stack. Anyways, one by one we'll be seeing the implementation of this also. Yes, shall I move further?
Yes, sir.
Okay. Now see, in the stack, I wanted to make two important points here. It has got hanged. Anyways, fine. Give me a minute. Yeah. So actually, what is a stack? As we have seen, it is a data structure of ordered items such that items can be inserted and removed only at one end. Only at one end. Okay. So we have seen now what all the operations that we can perform on this stack, that is very important, and which these are the operations which is we need to add while we are implementing the stack in a program. This is your experiment 2. You are moving ahead for the experiment lab experiment 2. Okay. Stack, then queues. Experiment 3 is going ahead with the third related with the queues. We'll be seeing one by one. So what can be what we can do on the things, we can able to do the push matlab we need to place an item on the stack. As I have said, we have drawn the table, and we have said the first element, then second element. This is what called as a pushing. Okay, skipping the element or storing the element. This is just a pick, is look at the item on the top of the stack and do not remove it. This is just viewing the topmost element. Popping is removing it. Look at the item on top of the stack. See guys, here as we are saying, top is the pointer which is pointing to the topmost element in the stack. Topmost element in the stack. This is the topmost element which is pointing out this book. Okay, so that if any of the next book, if I want to insert, I simply has to say, okay, this is the next position which is empty. You feel your next book over here, like this. Okay, so the top pointer will be pointing out next. In this case, we'll be discussing. Okay, uh, that's how the top will be working. We'll be discussing about the top also. Stacks, actually, it is a stack is a last in first out data structure, as we have discussed. Uh, it is also called as last in first out की जगह पे first in last out philo. Okay, or last in first out. So don't get confused between these two terminologies. People make you confuse for this. Whether you people mix will say about stack and queues, philo or LIFO, both are the same. Okay. A stack is sometimes also called as a push down store. Now, push down store. क्यों कहते रहेंगे इसको push down store? Can you tell me how why it has been called as a push down store stack? इसका मतलब क्या होता है बेटा? What do you mean by push down? Let's
Step
worry
by
about.
step, it is coming down, sir. The element which is in which we are keeping at first, we are keeping, it will
Okay.
become step by step. It will go down, sir.
Uh, yeah. Yeah. One way it is correct. See, guys, I'll give the answers for this. It is one of in one way it is correct. Let's assume we have one element. Okay, let's talk about one table only. That is a better example. Okay. Now here is the first element. Okay. Now this is the top, which is pointing, which is saying this is the element. Now if I want to insert the another element, this is the second element. Okay. Now this is the top pointer. Initially the top pointer here. For this element which was at the top, now it comes down. it comes down as another element got pushed. As another element got pushed, this element was coming down as the top pointer is not pointing to it. Okay, it is down on the element which is been pushed recently, which has been pushed recent. Now this is the topmost element, so it will say, okay, I am the topmost. When again another element is going to be inserted as the push, it gets down. This is not the first element or topmost element. Okay, so everything is depend on the top pointer. Top pointer will always pointing out the topmost element in the stack. That's why the pointer we are calling it as a top pointer, which will be pointing the topmost element in the stack. Okay, let me talk you about, there are the certain application that we will be seeing one by one. All these applications, right now I'll just simply name these, and as we start with the applications, we'll be seeing each and everything. Okay, so generally first it start with the how the program gets executed, then parsing, the parsing, we'll be talking about the parsing also, and then the evaluation of postfix expression, infix, postfix. We will be seeing this one question you can get over this evaluation of postfix expression for 4 to 6 marks. We will be discussing that also in stack, and you have one laboratory experiment over to this also. I am not sure whether it is third or fourth or what, but you have an experiment on this expression evaluation where you need to use the stack. Yeah. So let's assume class, I'll give an example of a stack. Okay. So you just tell me how will you perform the operation. Let's assume I have a stack. Stack is fixed memory. Okay, initial level. Let's assume I'm giving the number 0, 1, 2, 3, and let's assume it is 4. So I have the size is 5. Okay, I have the size of this stack is 5. Okay, this is the element. So total size is 5. Initially, let's assume I'll come back and tell these things. I have stored one element here, so my top pointer is here. Okay, the insertion and deletion both will be done from this one end only. Okay, this is a end where we can perform the insertion as well as deletion, that is push and pop operation you can perform on this. So top element, so one element is already here. I'll give the name as 1. Okay, now if I want to insert the another element 2, where it will come, guys? What happens actually? What happens? So here it comes, it will check, this is the memory location which is filled already. So the next memory location is, for that it will increment the top pointer first. It will check whether there is a memory available for the next memory to next element to be stored. So it will say, okay, we have the memory because the maximum size, maximum element that it can store is 5. Right now we have successfully stored only one element, so second memory location is available, so it will store 2 over here. Okay, once again, so 1 is stored, 2 is stored. Now I have the another element which has to be stored is 3. Okay, so top will first increment and check whether there is a memory location available. Yes, so it will say, okay, fine, you come and get inserted. So 3 has been inserted. Now check with the 4. Again, for 4 first it will increment and check whether the memory location is available. Yes, it is available. Then store. Then I'll add 5. It will first check, it will not directly add, first check whether the memory location is available. Yes, then add margin. Okay, now once again I'll ask, I need to store 6, so top pointer is pointing out here. Now guys, can you tell me what will be the next step now? Yes, what will be the next? As it is going to, this is the top pointer which is pointing out at 5. What I said, first it will check whether the memory location is available to hold the element. Can you tell me whether the so it will come, it will check 6 whether the memory is available.
No, sir.
Then are you able to store this element 6? Is it possible?
No, sir.
It is not possible. So such kind of situation is called as, if
Overflow.
you might have followed, कि आपके घर की टंकी होती है, ओके, जो आप कभी कभी इसमें पानी फिल पूरा भर जाता है, तो यहाँ से पानी निकलना शुरू होता है, व्हाट यूज्ड टू कॉल, कि टंकी ओवरफ्लो हो चुकी है. Such situation is this kind of situation where the top is pointing to the maximum element and still you want to insert. So this element will be simply drop out, yes or no? It is not possible. We cannot store that sixth element inside the stack. So it will be simply dropped out. Such situation is called as overflow. Such situation is called as overflow. We will be talking about the overflow also. In this situation, you have already seen, definitely you might have seen such thing. You might have used the word overflow also. Okay. So what can be the condition to check the whether it is been overflow? Because once you find the overflow, that stack is overflown, you need not to add, because you cannot add. Even if you try to add, that element cannot be the part of the stack. It will simply drop that element. It will simply drop that element. So there is no meaning. It cannot hold that element, right? So what can be the situation where you can say, okay, this is the overflow? It is, see, the maximum size is 5. So what I can say, if top equal to maximum size, because see, it was 4, when it becomes top plus plus 5 and 5 equals to 5, top equals to max size 1, you can say, okay, मेरा stack fill है, completely filled है, I cannot add any more elements into that. That's what, that is the problem actually. What happens if we try to pop an item of the stack when stack is empty? Okay, as well as I think I have come with another point. Okay, that, as well as what happens if the stack is completely filled. When the stack is empty, I did not tell you about the pop operation. Did I tell you about the pop operation? Pop के बारे में बताएं. Have we discussed about the pop?
No, sir.
Okay, fine. Let's discuss then. Say you have once again I'll take up the same example. You have this example where you can easily able to keep 5 elements. Okay, so 0th element, first element, 2, third, and fourth element. Now what happens? Let's assume, okay, the push is insertion. Push is for insertion. Pop is for deletion. Okay. Push will be done where it will be stored where the top pointer is pointing out. Pop is deleting the element which will be deleted for which the top is pointing. Okay, let's assume I have these elements stored 1, 2, 3. Okay, top is pointing to this. Top is pointing to this element, and I am doing push operation now. I am doing push operation. Okay, I'm adding push 4. What happens? What I said, first it will increment the top pointer. So here it will come 2 plus 1 is 3, and it will check whether the memory location is available. Means whether the top, first it will check whether the top equals to maximum size. That is whether the stack overflown. No, then it will increment and it will simply say, okay, we have the memory location available. Now you can make the insertion. So 4 is been successfully inserted. Now if I do the pop operation, okay, if I do the pop operation, in doing the push you need to mention which element you are going to store, but during the pop there is no meaning of mentioning which element you are going to delete. It only deletes the elements for which top is pointing. Now top is pointing to what? Top is pointing to this top of 3, which is 4. So when you say pop, it will remove this 4. from this. It will remove this element from this. Okay. Now, as it removes, top has to be pointing out the element which is the top in the stack. So यहाँ पे चला गया तो top में कौन रहेगा बेटा? top पे topmost element कौन है आपका अभी? कौन है? If this element will not be there, which is the element which will be the topmost now after removing the 4? Then top has to decrement because it was pointing out the 3. Now it has to decrement at and pointing to the this as it is the topmost element. Okay. So when you talk about the push, when you need talk about the push, top will be plus plus. When you talk about the pop, it has to be decremented. So that is what the question it is asking now. If in the stack, if it is in the stack, there is no element only. There is no element at the bottom. Okay. There is no element. Top is pointing out -1. Let's assume this 0, 1, 2, and top is pointing to -1. And you want to do the remove the element. You want to pop out the element. Is it possible to remove the element?
No, sir.
So such situation is called as underflow. You see, I have given the example of tank. Let's assume you have a tank, but it does not have any water. So can you able to remove the water from this? Not at all. It is not possible, right? In the same way, that kind of condition is called as underflow. Here also, if the stack is pointing out, the top of the stack is pointing out -1, because we are starting the first element of the stack with the 0th location. If it is pointing to -1, it is considered as an underflow. So I hope you understood the two important concepts of overflow and underflow. Yeah. Okay. Fine. So this much in the next class we'll be discussing about the complete implementation of the stack and its important program related concepts that we'll be seeing. The functions, we'll be talking about the functions also, how we can work on these functions. So stay tuned to the next class. We'll be able to perform as well as able to get around 8 marks question in the next class. Okay, so I'm stopping myself here because next concept are also very important and it requires a link. Okay, so here we are stopping. If you have